Okay, so that's why 23 squared for sure is bigger than 401, so we don't have to do it anymore. Understand? So if you can start with, you can stop at what? You can stop at 17 or 19, right? So 19 is the closest one possible because 9 times 9 equals 81. So last digit should be 1. So if I were you, I'm going to try 19 times 19. If 19 times 19 is not equals to 401, so 401 is not a square number.
What about 17?
Yeah, we can try 17. No, I'm talking about the square number. This is a prime. We're talking about the different things, okay? So this is because this one is already, when we're checking to determine whether a number is a prime or not, we only need to check prime factors. There's no need to check for divisibility by composition number like 4 and 10 because 4 or a factor of 2 would be a factor. If 2 is a factor already, 4 for sure will be a factor. Get it? So we don't have to calculate the composite number, just the prime number. If 10 were a factor, 2 and 5 would both also be factors. Get it, everybody? Okay, so we don't need to check all primes, only those which are less than the square root of the number we're checking. For example, when testing to determine whether or not 401 is a prime, we only need to test a prime up to 19. If 23 were a factor, it would have to multiply by a number less than 20. Get it? So that's the same thing. You can check the both prime numbers or square number. Understand? To determine whether a number n is a prime, check the divisibility by prime less than square root n, starting from least to the greatest. Okay, so please write down this one. I'm going to explain to all of you, okay?
老师，我纸快
嗯，
要没了。
那你赶快去再去买一个呀。
Yeah.
Okay, so everybody, let's take a look at this. How we using this number, okay? So determine whether a number is an M is a prime or not. Okay, chapter, for instance, if we have a number 181. So 181, we don't have to check all the way, but what? You can check 2, 3, 5, 11. We know the divisibility rule. They're not qualified, right? Because it's not a even number. The sum is not divisible by 3, and the last digit is not 0 or 5, and 1 plus 1 minus 8 is not divisible by 11. So all of them are gone. All I need to check is 7 and 13. Why only check 7 and 13 and no more? Because, 13 squared equals 169, and I know 14 is not, 17 squared equals 200 something. It's no more useful. So we all need,
289.
yeah, so yeah, I know 289, but it's too much, right? So that's why I only need to check 181 divided by 7, it's not divisible, and 181 divided by 13, it's still not divisible. So 181 is a prime number. Understand, everybody? Understand, chapter? Understand, Daniel? Okay, so those kind of questions has been asking a lot in the thing. Okay, so let's take a look at this one. Which of the following are primes? If the number is not prime, name it prime factors. So let's take a look at this one. 287, 391, and 503. Can you quickly do it yourself? The first one, 287, you can just, first of all, we can just square root number that and just to find out the closest number and you know where to stop. Okay, 287, which one will be the closest? I think Jason already told us, right?
17.
Very close to 17 squared, right? So I know this number, we only need to try 2, 3, 5, 7, 11, 13, and 17. Correct, everybody? But 2, we don't have to do it. 3, we don't have to do it. 5, we don't have to do it. 11, we don't have to do it. So all we need to try is 7, 13, and 17. Get it, everybody? Chapter, do you understand? Okay, actually, 17, we don't have to try it at all because 17 squared is equals 289. It's already bigger than that. So all we need to do is just the 7 and 13. So 287 divided by 7. Oh, we get it, right? So it's 41 times 7. So 287 is not a prime number. Get it, everybody? So the thing, two of them are the same thing. So please do it yourself.
Why do we not have a divisibility rule for 7?
The divisibility rule of 7 is pretty complicated, so that's why we don't, it's not useful. It's just easy for you to just divide it. It's quicker. Jason?
Okay, thank you.
Okay, so let's take a look at this one. So 391 will be closest to which number?
19.
Okay, so 19 squared equals what? 361, right?
61.
Yes. So if we square root it, I know it's 2, 3, so 2 is no more useful. 3, 5, and we only try 7 and 13 and 17. Correct, everybody? Okay, so if you starting to understand the prime factors better, you feel like actually most of the time we're trying 7, 13, and something like that, correct? Because before that, it's very easy to look, Daniel and chapter, understand? So because those of like, if this number is divisible by 3, chapter used to remember, we just add all the digits up. It's very easy and obvious, right? So 503, so 503 is closest to which number, Elaine?
22 squared or 23 squared?
Yeah, 23 squared equals 529, right? So we're just using 22, but 22 is not a prime number. So it's basically, we stop at 19. Get it? So if you take a look at this one, 503 is not fit for anything. So just try 7, 13, 17, and 19. These 4 numbers. Get it, everybody? Okay, I think you already know how to do these ones, right? Okay, so let's try to get Oliver. Do you understand? Doloma? Okay, so let's take a look at number 4.13. Okay, the number 13 is prime, and when its digits are reversed, 31 is also a prime. Besides 13 and 31, how many other two-digit primes are also satisfied with this condition? Okay, that means the number is a prime and reversed it is still a prime. So please find out all these two-digit prime number, which is the reversed and still a prime. Okay, so I think it's pretty easy, right? So 13 and 31, 17 and 71, correct, everybody? Is it 1991 one of them? No, okay, because 91 is not one of them. Very good. So all of the number which is starting with 2 is not a choice, because if you have the 2 as a 10th number, 10th digit, you think about it, you reversed it, the 2 will be what? Will be in the unit. So this one will be divisible by 2, right? So we start with 3. So 31 and 13. It looks like just a reverse, but it's also another one, right? So 37 and 73. Correct, everybody? Okay, I'm going to skip 4 as well. 5, no more 5, because 5, it is on the 10th place. Remove it, reversed it. It's going to be the digit place. It's going to be divisible by 5, which makes this number no more prime numbers. So I'm going to start with 7. So 71 and 17 is the one. And also what? 73 and 37 is the one, right? And do I miss anything? No? Okay, so let's take a look at number. Next one is 90. What? Because if I have 79 here, 97 here, and it will be 97 and 79 here. Okay, get it, everybody? I think this one is pretty easy. So let's move forward to the fundamental theorem of the arithmetic, okay? The fundamental theorem of the arithmetic states that every positive integer has a unique prime factorizations. For example, 5544 equals 2 cubed times 3 squared times 7 times 11. There's no other way to factor 5544 into a product of primes. To find the prime factorization of a number, it is often easiest to create a factor tree. If you remember your divisibility rules, this should be easy. Get it, everybody? Okay, remember, we also learned the short division one. Okay, so chapter 448 divided by 2, 224 divided by 2, 112 divided by 2, 56 divided by 2, 28 divided by 2, 14 divided by 2, 7. Remember, everybody? Okay, so this way and this way, both of them are working. Okay, nothing is better. Okay, so we just do a very quick one. Yeah, let's just write the prime factorization of each of the prime below. These three numbers all have something in common. Can you tell me what it is? Okay, so 4.630. Okay, so I think this one everybody already understand it, right? Because their factor is actually come back as a pair, right, Elaine? Right, so there, which is called a what chapter? If the factors is always coming up like a paired, we call it what? Square number. We call it square number. Okay, understand, everybody? Okay, so now let's move forward with a perfect square. Okay, so 441, 256, and 576 from the previous practice problem are all perfect squares. If a number is a perfect square, each of the prime factors will have an even exponent in its prime factorization. What does it mean? Like, that means the factor, they come up with pairs. It's always paired. Correct? What perfect square is represented by 3, 4, and 5 squared? So you can say, in order to get a perfect square, we must have something squared, right? And you can see 3, 4, 5 squared, very easy. We can just put 5 inside. And 3, 4, can we change it to 9 squared? So that's why equals 5 times 9 squared. So it's 45 squared. Understand? Okay, so now 1, 2, 3, please. So I can do another one example, okay, chapter? Like x squared equals 4, 6. Sorry, it's too big. Just to make it easy for all of us. So equals 2, 6 times 3, 4. So could you please tell me what is x represent? Very easy, because that's equals to 2 power 3 times 3 power 2 squared, correct, everybody? So that's why it's 9 times 8. So this is 8, this is 9, and squared. So it's 72 squared. So x equals 72.
Why do you look so tired?
Really? I don't know. I guess I have a busy day today. Okay, so let's say 5 to the power of 4 and 2 power of 4 and 3 squared and 2 squared times 3, 6 times 5 squared. Okay, so please tell me. Okay, so I am going to ask Daniel, could you please tell me the first question? Very easy. Daniel. 没听课, okay, 好.
Is it 625?
So what perfect square are represented below? So we want to know the perfect square number, so it should be 25 squared. Get it,
Oh,
Daniel? Yeah, that's the answer I'm expected. That's the thing, okay? So next one, I am going to call Jason.
I got 12 squared.
Okay, so because 2 squared, so we have 4 squared times 3 squared, so equals 4 times 3 squared, so equals 12 squared. So the answer is 12. Very good. Okay, last but not least, Oliver, can you tell me the answer?
It equals 4 times 25 times.
No, you're not listening either, okay? If you're listening, you know exactly what I'm expected from you. Get it, Oliver? You're not listening. Okay, so the thing is, we're having a Zoom class. It doesn't necessarily like I need to just pick on you all the time, right? Okay, Elaine, could you please tell me the answer, please?
270 squared.
So we can just, if this is 2 times 3 square, sorry, cube, times 5 square. Correct? Okay, so it's, if you do that, it's 270 squared. Get it, Oliver? I don't want to get this one. I just want to know what is, get it, chapter? Okay, so let's take a look at next one. Okay, so counting the factors. One way to count the number of factors that a number has is to list them, right? So 40 has 8 factors and 96 have 12 factors and 196 have 9 factors. But remember, everybody, actually all the factors could be using another way. When you list the factors, list them in pairs and go from least to the greatest. There's a nice relationship between the prime factorization of the number and its number of the factors. For example, look at the prime factorization. 40 equals 2 cubed squared, sorry, 2 cubed times 5. Okay, so if you take a look at the 2 cubed and times 5, you can think E1 is one of the factor, equals 2 power 0 times 5 power 0. Right, and 2 equals what? Equals 2 power 1 times 5 power 0. And 4 equals 2 power 2 times 5 power 0. And 8 equals 2 power 3 and times 5 power 0. Got it, everybody? Okay, so if you have these ones in your notebook, then you know that the number of the factors is exactly 2 to the power 3 times 5 to the power 1. They have this one. So why we are doing 3 plus 1 times 1 plus 1 chapter, okay? Because in order to use a factor 2, we're actually having 4 different possibilities. Is either not having any 2, 1, 2, 2, 2, and 3, 2. And for the usage of 5, it is either having no 5, F1, 5. So for each of the line we cross, we can have how many? We can have 8 different factors there. Get it, chapter? Get it, Jason? Okay, so that's why it's, because the possibility of using 5 is 1 plus 1. And the possibility of using 2 is 3 plus 1, because don't forget, there's always a possibility that we don't need it. Get it? So that's why it's 8 different possible answers. So if you take a look at 96, that's the same thing. So 96 divided by 2 equals 48, divided by 2 equals 24, divided by 2 equals 12, and divided by 2 equals 6, and divided by 2 equals 3. So 96 equals 2 to the power 5 times 3 to the power 1. Okay, so how many factors are there? 5 plus 1 times 1 plus 1. So the answer is 6 times 2 equals 12. Got it? Okay, so based on this techniques, we can find out all the factors, okay? So how many factors does 56 have? We can have,
56?
yeah. How many factors does 56 have?
4. Wait, no.
Okay, so 56 equals 2 to the power 3 times 7, right? So that's why 3 plus 1 times 1 plus 1. So everybody, do you know where I get this one? Because we only have 1, 7, and 3, 2. So altogether, we have 8 factors.
Wait, so you get the 3 from the exponent, right?
Yes, yes.
And then where does the other one come from?
Because we have,
Like the one after it.
yeah,
Oh,
it's a 1 exponent.
okay.
Get it? Okay, so now let's see. How many factors does 240 have? Okay, so this question should be very easy. Chapter, can you help me to do this one together? So first of all, we need to just to make the 240 as the prime factorizations, right? So how do we do it?
Divide by 2.
Divided by 2, very good. So equals what?
120.
And divided by 2 equals?
60.
Divided by 2 equals?
30.
Divided by 2 equals?
15.
And divided by 3, sorry. I cannot tell you. Divided by 3 equals 5.
5.
Yeah, so 240 equals what? 2 to the power?
4.
Chapter, do you understand? 2 to the power?
4.
4, very good. Times 3 times 5, correct? And for the top is 1 and 1, right? So how many factors? 4 plus 1, chapter, times 1 plus 1, and times 1 plus 1. Get it?
20.
So the answer is 5 times 2 times 2 equals 20 factors. Understand? Okay, so if you both understand, so let's do 1 and 2. 4040 and 4140.
Sorry, what number were you doing again?
Circle 1, these two.
Alright, thank you.
Okay, so I am going to ask the first question, A, for Daniel 到哪去了? For chapter, B for Oliver, C for Jason, and D for Elaine, okay? Okay, so first question, chapter, could you please tell me the answer?
10. 10 factors.
Does everybody think it's right?
I had 12.
So chapter, take a look, okay? So 72 equals 2 to the power 3 times 3 to the power 2, right? So we just discussed about the exponent part, okay? Chapter, take a look. So because the usage of 3 2's is 1 2, 2 2, 3 2, and also a 0 2. So that's why 3 plus 1. And the usage of 3 power squared equals what? 什么意思？就是2个3乘起来，对不对？说明在这个72里面有 2, 3 as a factor, right? So we can use 3 0, 3 1, and 3 2. So there are 2 plus 1 possibility. So it's 4 times 3 equals 12 factor. Understand, chapter? Okay, number 2, Oliver.
12.
Okay, so the number B is still 12. It's 1 plus 1 times 1 plus 1 times 1 plus 1 times 1 plus 1. So equals 2 times 2 times 2 times 2 equals what? Equals
16.
Okay, I'm sorry, Oliver. You get it wrong as well. Okay, number C, Jason.
18.
Okay, Jason thinks 18 because we have 2 plus 1 times 2 plus 1 times 1 plus 1 equals 3 times 3 times 2 equals 18. Good job, Jason. Very good. Okay, last but not least, Elaine, could you please tell me the answer?
10.
Very good, because 102 equals 2 to the power 4 times 7 to the power 1. So it's 4 plus 1 times 1 plus 1 equals 10 of them. Okay, chapter. And Oliver, do you understand? How to use it? Do you want me to explain again?
How is 12 wrong?
Number B,
Yeah.
because 2 times 2 times 2 times 2 equals 16.
It's actually just 2 to the power of 4.
12? But 12 is 2 squared times 3.
Huh?
12.
No, we're talking about this question. So 210 equals 2 power 1 times 3 power 1 times 5 power
Oh,
1.
I thought it was the next question.
No, we're talking about this one, A, B, C, D. Okay, so what is the smallest positive integer that has exactly 6 factors? Okay, so everybody, how to have 6 factors? We have actually a to the power 5, right? So 5 plus 1 has 6 factors, right? Or we can have what? We have a power 1 times b power 2. Because these numbers are going to be 1 plus 1 times 2 plus 1 equals 2 times 3 equals 6. Get it, everybody? So we have to have what? The a and b. So 100 power 1 and b squared. The smaller the better. The smallest possible integers. So I'm going to put b as what? 2, because that's the
2.
smallest factor, and the 3. So the answer is 3 times 4 equals 12. Okay, Oliver? Sorry. Okay, so now do you understand, everybody, this one? So we're going to move forward to see 420. Okay, exactly 10 factors. Okay, so I'm going to explain this one. What is the smallest positive integer that has exactly 10 factors? So you have to think about it, how we can get 10 factors. There's only two possibilities, either a to the power 9 or a1 and b4. Get it, everybody? Because the prime factor number will be 9 plus 1 and 1 plus 1 times 4 plus 1. Get it, everybody? Okay, so this one, will be pretty big, 2 to the power 9, right? Because we want to get this one smallest, the better. The prime factor will be 2. Or we can have 2 to the power 4 times 3 to the power 1. I think this one will be much better than 2 to the power 9, right? So the answer will be 16 times 3 equals 48. That is the smallest possible positive integer that has exactly 10 factors. Understand, everybody? Okay, so now we're going to go forward. And let's take a look at this one, okay? Trickier factor counting. Okay, so let's take a look at this one. Odd, even, and square. How many odd numbers are factors of 240? Okay, so before we are only talk about the factor numbers. So now we're talking about the odd factors. So let's just starting with something smaller, okay, Jason? So 24 has what? 1, 24, 2, 12, 3, 8, and 4, 6, right? So for 24, this number, we exactly have 8 factors. Correct, everybody? But how many odd factors we have? 1, 2, and that's it. Okay, so even factor will be the total factor minus 2. So it will be 6 even factors. Get it, Elaine? Okay, so, but the thing is, it's impossible for us to list all of them, right? So how do we find out the factor of odd? The reason we're finding the factor of odd chapter, we need to understand what is odd number means. Odd number is always the number without the factor of 2. Get it, Jason? So you can see 13, or we can say, let's see, 51. 51 equals 3 times 17. And 51 or 3 or 11 or whatever, all the odd number doesn't have at all what? Even factors. Or we can say there's no factor 2 existing in the any odd numbers. Get it? Okay, so let's take a look at this one. For 240, we equals 2 to the power 4 times 3 to the power 1 times 5 to the 1, right? Just to get rid of the even part, or we say the factor of 2 part. Then the whatever left here is the one that you are going to get the even number, sorry, odd number, which is 1 plus 1 times 1 plus 1 equals 4. Why does 1 plus 1? Because as a factor of 3, we can have 3, 0, and 3, 1. And as a factor of 5, we can have 5, 0, and 5, 1. So you times them, and you times them like that. So you can have exactly 4 numbers. And you can see it's 1, and it's 5, it's 3, and it's 15. Exactly 4 of them. Understand? Okay, so when you find out how many odd factors of 240 has, which is 4, and it's very easy for you to find out the even factors. Okay, the even factor is 4 plus 1 times 1 plus 1 times 1 plus 1. So equals 5 times 2 times 2 equals 20. So 20 minus 4 equals 16. So 6 of them are even and 4 of them are odd. Get it, everybody? Okay, so let's take a look at this one. How many perfect square number are there for the 360? Okay, so if you list them, is 1, 360, and 2, 180, and 3, and 120, and 4, and 90, and 5, it's 72, and 6, 60. There are a lot of them, right? But the thing is, again, we look at the prime factorization, it's going to be easy. So because 360 equals 2 to the power 3 times 3 to the power square and times 5 to the 1, right? We need to find a factor that including only even powers of 2, 3, and 5. So we have 2, 0 or 2, 2. Why do we need to have the even power, everybody? Because square number is actually having at least one pair of the same factors. So when they're same, you have the even power, right? For instance, you have 2 4s, you equals 4 squared, right? You have 2 times 2 times 2 times 2, you have 2 power 4. Correct, everybody? Okay, so let's take a look at this one. So we have 3, we have 3, 0, or 3, 2, right? But 5, 1 cannot be used because Elaine, it only have 1, 5, so they can never be the factors of any numbers, right? So that's why, because we have these ones, so we have this one equals 1, and 2 squared equals 4, and 2 squares equals 4, and we can just time them together equal 36. So there are 4 of them there. Get it, everybody? Okay, so let's take a look at some questions to practice data, okay? So I'm going to check some questions. So 1, 2, and 3. Okay, Oliver 不要再做错啦。Okay, so first question, who wants to answer? I think this one's pretty easy. Elaine, do you want to try? Or only one, what?
I think 17.
Huh? Even.
Even?
Yeah, let me see. 1, 4, 0. Yeah, let's take a look at this one. How many factors of 480 are even, okay? So let's take a look at this one. So 480 divided by 2, 240, divided by 2, 120, divided by 2, 60, divided by 2, 30, divided by 2, 15, divided by 3, and 5, right? So 480 equals 1, 2, 3, 4, 5. 2 to the power 5 times 3 to the power 1 times 5 to the power 1, right? So Elaine, how many factors are there in total for 480? It's 6 times 2 times 2.
24.
24, right? How many of them are odd? 1 plus 1 times 1 plus 1, right? Equals 4. So how many of are even? 24
20.
equals 20. Get it, everybody? If you have any questions for that one, you need to stop me and ask me right now. Get it, everybody? Okay, number 2. How many of the factors 440 are even? Daniel, 有知道 Daniel 你在吗 Daniel, are you there? Jason, how about you try it?
That
didn't
thing
get-
wasn't check mark, so I only did the one under it. I'm sorry.
啊，这道没做。
Yeah, because sorry, I did that one, my bad.
Yeah, 你做了呀。对，你做的对的。So 440,
I got 12.
12. Okay, is everybody the same as Jason? So we have 440 divided by 2, 220, divided by 2, 110, and divided by 2, 55, and divided by 5, 11, right? So 2 to the power 3 times 5 to the power 1 times 11 to the power. So how many of them are odd? Will be 4. How many of them are in total will be 4 times 4 equals 16. So 16 minus 4 equals 12. Good job, Jason. Okay, so let's take a look at 4.35. Oliver, how many of the factors of 1, 2, 9, 6 are perfect squares?
I'm still doing it.
Okay, so everybody, do you need more time? Okay, I give you more time. So do you need my help for this question? Okay. Jason, do you mind to send it to me? How many? Okay, Daniel, good job.
Okay.
Daniel 做对了啊，很好。Okay, so let's take a look at this one. So 1296 equals what? 2 to the power 4 times 3 to the power 4, correct? Okay, so we can use the even factor. So this one we can have what? 2 to the power 0, 2 to the power 2, and 2 to the power 4, right? So how many options are there? 3. Okay, for the 3, we can have 3 to the power 0, 3 to the power 2, and 3 to the power 4. How many options are there? 3. So 3 times 3 equals 9. So there are altogether 9 different perfect squares are there in the factor of 1296. Okay, so now let's take a look at number 4.45. Okay, so this question is a little bit harder. So I'm going to just to help you. So give you 2 minutes to try to do it. If a number n has exactly 7 factors, how many factors does n squared have? Okay, note that it is a odd number. Remember, I told you before, like usually all the numbers, all the factors in our world is always what, Jason? Is always even factors. 对不对？都是8个、10个、12个 because usually the factors coming up like paired. But only if when you have a special case is when the number is a square number, you have the odd number of the numbers. Correct? Odd number of the factors. Correct, Elaine? Mhm. 想一想啊。So everybody, with a number that has exactly 7 factors, this number must be n must be a power 6. Correct, everybody? There's only one possibility because 7 is a what? Is a prime number. So how many factors does n squared? Because n equals a to the power 6, so n squared equals what? A to the power 12. Am I right, everybody? So how many factors does this one have? Is 12 plus 1 equals 13 factors. Good job, Jason. Very good. Okay, so everybody, let's take a look at this one. So the circled one, 4.850. How many perfect square less than 400 have more than 3 factors? Okay, something like that. It's getting harder, I know. But I'm going to help you, so don't worry about it, okay? 先自己做做看。You know what? Let's just don't jump all the questions, okay? Let's do yeah, let's don't jump all the questions because all of them are, I think it's easier, it's hard. So how many 3-digit integers have exactly 3 factors? Let's do 4.450. Sorry, 4.550. Everybody, 3 factors. 3 is also a prime number, correct? So this number we said this number, we can say it's n equals what? Is it equals to a squared? Correct? Okay. So let's take a look at this one. And this a must be what? Must be prime. Why it cannot be anything but prime? Let's take a look at this one. If we say if we said it's 4 squared, so it could be written as 2 to the power 4. So now immediately change to factor number will be 5. Correct? So this number must be prime. So let's take a look at this one. Which is the smallest 3-digit number? 11. 11 squared equals 121. Right? So this is 121 is the number that only have 3 factors. Is 1, 11, and 120. So we have 13 squared, 17 squared, 19 squared. And when to stop? Is actually, you think about it, 33 squared for sure is bigger than 1000, right? So which is 4 digits. So which is the smallest number? Biggest number, which is smaller than 33, it's 31 squared. Right, so we are having 19 and 23 squared and 29 squared and 31 squared. So we have 1, 2, 3, 4, 5, 6, 7. So 7 numbers which exactly have 3 factors. Understood? Chapter? Chapter 好像不动了。Elaine 在动 Jason, oh, okay. Oliver, do you understand? Okay, so let's take a look at number 4.650, okay? A number n is a multiple of 7 and has 5 factors. Okay, so everybody, n equals 7 times something, right? So we can say a, right? Multiple 7 and no. N equals 7 power 4. We can say that. Correct. And we can also, how many factors does 3n have? So 3n equals 7 power 4 times 3. So how many factors are there? 4 plus 1 times 1 plus 1 equals 10. Jason, 8个屁！5乘以2等于10还是5乘以2等于8？
My bad.
Elaine, do you understand? Oliver? Okay. So now let's take a look at number 4.750. 4.750和4.650很像啊。 Okay, the number p is a multiple of 6 and has exactly 9 factors. So it must be 6 power 8. Correct? Chapter, understand? Because the number of the factor is exactly equal to the power plus 1. So 10p equals what? 10p equals 10 times 6 power 8. But 10 is, oh, sorry, this one's wrong. What I'm doing? No. P equals 6 power what? I don't know, right? But exactly, they have 9 factors. I'm wrong. Sorry.
Yeah.
Why I cannot directly using that one? Because 6 is not a what? 6 is not a
Prime.
prime number. So we have to get it as 2 power a and 3 power a. Get it? Because 6 equals 2 times 3. Okay, so a plus 1 times a plus 1 equals 9. So who can tell me a equals what? A equals
Is it 2?
right? So p equals 2 squared times 3 squared. And now 10p equals what? 10p equals 2 squared times 3 squared times 10. Again, 10 cannot use directly because 10 is not a prime number. I change it to 2 times 5. And putting them together equals 2 to the power 3 times 3 to the power 2 times 5 to the power 1. Okay, so we have 2 to the power 3, 3 to the power 2, and 5 to the power 1. So how do we find it? So 3 plus 1 times 2 plus 1 times 1 plus 1. So times together equals 4 times 3 times 2 equals 24. So 10p has 24 factors. Okay, I'm going to stop here and let you think about it. Do you understand these questions? Oh, do I have to explain again? You understand? Okay, very good. Okay, so now let's take a look at number 4850.自己做一下啊。Less than 400. So this is actually, we can just list all the numbers which is less than 400 and find out how many of them are having more than 3 factors. Correct, chapter? So 1, 4, 9, 16. 就是因为它没有多少嘛，对不对？那有一些像这个个位数的，我是不是都基本上不用啊？So 81 should. So we can see 1, 4, and 9, they're nowhere, right? So this one equals 2 to the power 4. So obviously, this having more than 3 factors, correct? And 25 is no more because you can see those of them squares, 1 squared, 2 squared, and 3 squared, and 5 squared. We can just take all the what? 比400小的 perfect factors, only 20 of them, correct? Actually, we can only take what? Take all the factors, sorry, take all the square numbers, which is made by the prime number. This one. Get it? So 1, sorry. Yeah, 1, 2, 1 squared, 2 squared, 3 squared, 7 squared, 5 squared, I almost finished, and 11 squared, and 13 squared, and 17 squared. You just minus all of them. Get it, everybody? Yeah, so that's pretty easy, right? So let's take a look at number. What is the smallest positive integer that has exactly 18 factors? Okay, let's take a look at this.有人做出来的吗，小朋友们？今天的好像有点，大家有点呆哦，觉得有点难，是不是？
Yeah.
我觉得还好啊，就
Actually,
yeah,
no.
numbers here.
Give me a moment.
Okay, how many perfects? I'm sorry. What is the smallest possible? So exactly 18 factors. Factor in order to get 18 factors, 是不是可以 a 的 power 17？那这个我们肯定不考虑，对不对？哪怕是2的17次方，这个数都很大，对不对？ Okay, so we need to make them as possible, as smaller as possible. So 18 could equals what? 18 could equals to 2 times 9. Or could equals to 3 times 6. Or actually, you can prime factorization. 18 equals 2 times 3 times 2. No. 2 times 3 times 3. Correct? Okay, so this is my target. I want to have something 1 plus 1 times 2 plus 1 times 2 plus 1. Get it, Elaine? Okay, so now we have what? A to the power 1, B to the power 2, and C to the power 2 equals this number. So I want to make the smaller number on the bigger equation. So we can put a 2 here, and here is 3, and here is 5. So this number will be 5 times 9 times 4. So this number is 180. So 180 is the number that is smallest, which have exactly 18 factors. Everybody, 4.60, if you understand all of them. So let's take a look at the next one. What is the smallest positive integer that has exactly 16 factors and which is not divisible by 6? If not divisible by 6, Oliver, this number cannot have the factor of which two numbers?
Two and three.
Very good, 2 and 3. Okay, so everybody, this is our last question. Try to do it yourself. Okay, so I'm going to start to explain, okay? Since nobody gave me the answer, 每个小朋友都陷入了常考. Okay, exactly 16 factors. So what I want is having a number like 2 times 2 times 2 times 2. Right, so how do I get 2 times 2? Is 1 plus 1 times 1 plus 1 times 1 plus 1 times 1 plus 1. Get it? Jason, correct? Okay, but the thing is this number cannot be divided by 6, so what should we do? This number cannot be divided by 6, so that means it's a power 1 times b power 1, c power 1, and d power 1. And a, b, c, d cannot equal to 2 or 3. So then we're starting with what?
4.
5. 怎么会有 4 呢? Prime number, yes, Jason. 5, 7, 11, and 13. Stop me when you have any problems, okay? If you don't understand any of them, please stop me and I can explain again. Oh, sorry, I was wrong. It said cannot be visible by 6. I can still have 2 or 3. I just cannot have them both. Oliver, correct? I'm right? Sorry, I was wrong for this question. Jason, correct? It cannot be divisible by 6. If I have 3, but I don't have 2, then it's good, right? If I have 2, but I don't have 3, then it's good. So Elaine, I want to ask you, do you want to pick 2 or pick 3?
2.
Very good, because we want to make this number smaller, the better. Okay, so it's 2 to the power 1, and 5 to the power 1, and 7 to the power 1, and 11 to the power 1. But is it possible the smallest answer? Maybe. Let's just take a look at this one, okay? So because before, for the earlier one, because the numbers only can be, but 16 is a weird number, okay? 16 is a weird number. Let's take a look at this one. So is it possible like we have 2a to the power 3 times b to the power 1 and c to the power 1? Let's see, because in order to get rid of 3, we have the factor of 11. This is pretty big, right? So 70 times 11 equals 770. It's pretty a big number. So let's see if it is we can get anything smaller than that. Or we can also have a to the power 7 times b to the power 1. This also can get 16 because 7 plus 1 times 1 plus 1. Correct, everybody? Am I right, Oliver? Okay, so let's take a look at all the possibilities. So if it is a to the power 7 times 3, sorry, 5. There's no need to be 5. Okay, no 3. So it's 640. Okay, and this one, if we have 2 to the power 3 and times 5 and times 7, we have 40. 8 times 4 equals 584乘以7, we equals 280, correct? Okay, correct? So this is much smaller than those ones, correct? So we get this one. This one's still the best answer. The answer is 280. Get it, everybody? Okay, so this homework will be a little bit hard, but I have already go through the harder question for you. So today's homework will only just one piece of paper. 就只有一页纸 okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 只有13道题目 okay? So everybody, could you please do it yourself? 好吗? Okay, so if you don't understand, you can always go back to take a look at the video because the video is pretty much explain everything here. Okay, chapter? 好吗? Okay, so that's it for today's class. We're going to see each other next week. Okay. Oh, no, there's no class for next week. Yeah. Yes, there's no class for next week. But I'm going to tell everybody in the WeChat, let your parents know. Okay, everybody. Thank you for joining the class and see you next day. Bye bye.